All right, picking up where we left off. Last time we looked at entering the data and how to get a scatter plot of the data, and also how to find our correlation coefficient and the equation of our line of best fit here. What I want to look at this time is how to graph the line of best fit so we can see that it goes fairly close to hitting all of those points. And I also want to look at how to use that to maybe understand the situation and maybe make some predictions. So sticking with the same data, we go to our home screen to do our linear regression, stat, over to calc, and then down to linreg, enter. Now don't hit enter again. What you want to do before you hit enter is vars, arrow over to yvars, and then, yes, we want a function variable, so enter. We want y1, enter. Now what this says is calculate the line of best fit, that's what linear regression is, and then store it in y1. So when we hit enter now, it does the same thing it did before. It gives us our a, our b, and our r squared and r. But if we look in y1 now, it has stored the line 1.37x plus negative 4.5. We don't have to write it down and copy it over and type it into the calculator. It'll do that for us. And then if we go to graph, we'll see that that line does do a pretty good job of going through the data. Comes fairly close to hitting all of the points. Doesn't do a perfect job, just a pretty good job. But as we saw before, the correlation was 0.955, so that is actually fairly close to perfect. All right, now what can we do with this line? Let's take a look at trace. We go to trace, and notice up here it says 0.1 L1, L2. And that means that it is on the point that represents our first pair of numbers in list 1 and list 2, which you can see here are 10 and 7. And if we hit our sideways arrow, it scrolls through. I'm sorry, it's saying 0.1 or P1. I'm not sure exactly what that means. The L1 and the L2 tell us where the numbers are coming from, 10, 7. Then you hit the arrow and it goes to 2018. Arrow again goes to 30, 47, etc. And you can scroll through those individual points. I don't want to use the points though, I want to use the line. So to get from the points to the line, I'm going to hit either my up arrow or my down arrow. Right? It scrolls between showing the line and the points. So if I hit my down arrow there, I'm looking at a point on the line and it's saying 30, 36.6. Meaning, if this was a perfect linear correlation between these two data sets, right? If it was the same as legs and eyes or whatever, something that worked perfectly, then this would be 30, 36, not 30 and 47. And I can use my sideways arrows to find as many points as I like on this linear regression, or I can type in numbers. So if I type in 20, boom. If this was a perfect fit, then this would have been 20, 22.9 instead of 20 and 18. And what about 25? What if I was curious about somebody who had 25 in the first column? What should they have had in the second column? 29.75, a little less than 30. So we can sort of not make a prediction, but we can say somebody that was at 25 over here should have been at 29.75 over there. That's called interpolation. You don't need to know that word, but my data goes between 10 and 50. Anytime I look between 10 and 50 to see what my linear regression line says about something between 10 and 50, that's called interpolation because we're working inside the data set. If I want to go outside the data set, like say, what if I'm curious about what would happen at 70? What should I get for my second number here? Well, I'm going to have to change my window first. Right now, my x-axis, right, x-min and x-max says the x-axis should go from here to there, from 6 to 54. I need to go farther now. I need to go out to, I'm going to go to 80. I need to go at least to 70. I can go as far as I want. So now if I go to trace and put in 70, whoops, see, I hit trace and I was on my points. I try to put in 70. I don't have a point for 70, so it gives me an error and throws me back to the home screen. I put in, nope, not going to work. So I do trace and then up arrow or down arrow to get back to my line. And then I can put in 70 and it'll say somebody with a 70 in the first column ought to have 91.4 in the second column. So this here, interpolation, because we're working inside the data set, and this, we're going beyond the data, assuming the trend is going to continue, that's extrapolating. And that is that.